this thing. So you want to find it, you say 70 kilonewton per meter cube divided by 3 meter by 1 meter. You are changing it to this, whereby you are going to get 250 kPa. So in finding the factor of safety, what do? The factor of safety will give us the bearing capacity equation over the gross bearing capacity. So when you divide it, you get the factor of safety to be 5.5. You see that this time the factor of safety is higher.
Yes, sir.
It's no more 3, but when you calculate it, it's higher because it's where? In clay sand.
Okay.
Have you seen that?
Yes, sir.
Yes, sir.
So it depends on where you are calculating this thing. You see, the load is 75 kilonewton per meter, and you are changing it, right?
Yeah.
Right? You have to change it to the force, to the kilonewton. So it should be, the per meter is what? Times 1 meter. Then this one also. So since we have this, then we can have our factor of safety. So the same chart, the same goes to this thing. Then they said that what? For the effect of groundwater table, they said that a Tizadi analysis above assumption that what groundwater table is far below the foundation. That is greater than a depth of B below footing. So the groundwater table also, the effect of groundwater table, if the groundwater table is above the foundation, we try to avoid this light. We try to avoid this happening. Okay, this black, where we have the DF is what? The depth of foundation. D1 and D2. This D1 here is from a ground level to a portion of what? Of the column. Then a D2 from the portion of the column to the end of the foundation. You understand? Hello?
Yes, sir. So if the question asks you, the water table is 1 meter below the foundation.
Yeah.
It means, are you going to use 1 to do your calculation, or you are going to use the 0.5?
You are going to use, you said if the question again.
The water table is at 1 meter below the foundation. So I wanted to ask, are you going to use the 1 or you are going to use the 0.5?
I'm coming. You use the 1.5. Hello?
Hello, I'm talking about the water table.
Yeah, the water table, I'm coming. If the water table is
1 meter below the foundation,
you can still use the 1.5. Okay?
Okay.
You can still use the 1.5 to do the calculation.
Okay.
Because the water table is below is below the 1.5. It's below the foundation. When it's below the foundation, you can use the 1.5. But when it's above this thing, you have to use the 0.5. Okay?
Okay.
Yes. You have to use the 0.5. They said the previous example. Now, we come to the previous examples. We come to another example. They said in the previous example, we assume that the surface and a y is equals to this, and y stat is also equals to this. We're taking all the parameters to be the same. We're taking the parameters to be the same. Now, this time, we find the groundwater, we assume to be 1. The saturated water, which is a lambda, is also giving us 18 already. Then we also put in our parameters, and then when we vary the distance, when we say if it's only 0.5 meter below the surface, so what do? We also use the same procedure to solve the equation, and we get. So, hello?
Hello.
Yes, so it varies. It's not necessarily using when it's 1.5. When sometimes the groundwater is also is only at 0.5 meter below the surface. You can use 0. This is not necessary that always you have to use the 1.5. Okay. Yes, it depends on the nature of the soil and the depth at which the water will be found. Now, in this one here, we say that the groundwater table is only at 0.5 below the surface, only 0.5. So when it's only 0.5 here, then which means that we can still go ahead to use our 0.5, okay, to do our calculation to find for the gross bearing capacity of the soil. And then after we find the gross bearing capacity of the soil, then we can go ahead to find our factor of what? Of safety. Do you understand that?
Okay.
Right. So that is what we have. But last we talk about the main hub also. We talk about the main hub, and I believe with the main hub, you guys have gone through. Hello?
Hello, sir.
Yeah.
But you've gone through with this, the main hub, with the main hub equation, bearing capacity equation. We did all these things last week where we say QU is the ultimate bearing capacity. The C is the cohesion. Then we say the Q is the stress at depth of foundation, which is equal to lambda DF. Then lambda is average unit weight of soil under footing. The average unit, the lambda is the average unit weight of soil under footing. Then we say Q lambda is due to Q if completely submerged. So lambda will equals to lambda prime will equals to lambda B. And the B is always given as width of foundation. And that is diameter for circular foundation. So we say that our QC, our lambda CS, lambda QS, and lambda S will give us the shape factors. Lambda CD and lambda QD, lambda CD, lambda QD, lambda D will give us the depth factors. Then lambda CI, the lambda QI, lambda I will give us load inclination factors. There are our parameters NC, NQ, and N lambda are the bearing capacity factors. They are the bearing capacity factors. And our bearing capacity factors, as we said, that Mayhoff came out with these equations. And last I was saying this equation should not be scary to you. It should not look any scary to you. Mayhoff explained all these things. We have the shape factors where it's given us for phi equals to 0. We said our lambda CS will give us 1 plus 0.20. Our breadth divided by that falls within the range of phi will give us phi lies between 0 and 10 degrees Celsius. To interpolate between phi is equals to 0.
Hello. Rita. You're in.
What Tizagi also tried to use when we have the Q and give us 1 plus 0.10 D over L and tan square for the Tizagi. Hello? Hello?
Yes, sir.